Hi, and welcome to TEMEKO. In this video, we'll move on to discuss about potential energy. But before discussing about it, we have to understand what energy is in the first place. This is something we haven't really covered that much in any part of our mechanics courses, and yet it's one of the most important concepts related to mechanics. We can consider energy to be a capacity of doing some kind of work. For instance, kinetic energy that is related to the motion of the particle tells us something about the magnitude of the particle's motion when the work is applied on it. Another type or form of energy is potential energy, which tells us, on the other hand, how much energy an object can store in itself when the work is done to move it from a reference plane to a new position. If we let the particle move back to its reference plane, its potential energy will be converted back to kinetic energy. But keep in mind that some amount of potential energy would also be converted to heat energy because of frictional forces that are doing work to stop the motion of the particle. There are two different types of potential energy that we are usually interested about in mechanics. These types of potential energy are gravitational and elastic potential energy. Let's use the same lifting box case that we used earlier to understand gravitational potential energy better. If we first move the box in the upward direction from its reference plane, which can also be called a datum line, then the weight of the box will have positive gravitational potential energy because of the positive work it can do when we let the box move freely back to its datum. On the other hand, if the box were initially located under the datum and we want to move the box back to the datum, then the box would have negative gravitational potential energy because of its weight, which is doing negative work on the box. Of course, if the box remains on the datum, then it doesn't have any gravitational potential energy at all. Now, by knowing how the weight and vertical displacement are related to the gravitational potential energy, we can write a mathematical expression for it as follows. Notice how this equation is actually the same as the equation of the work done by the weight of the particle. This proves to us what we have learned during this video, that energy is the capacity for doing work. In case of the elastic spring then, the spring would gain elastic potential energy when we are stretching or compressing it by a certain distance s from its unstretched position. Notice how this elastic potential energy will always have positive values regardless of whether it's compressed or stretched. If you think about it, the spring force is always doing positive work because the force tries to return the spring back to its unstretched position. That's why the elastic potential energy can't ever have a negative value. To determine the possible elastic potential energy of some spring configuration, we can use the following equation. Notice that here the relation between energy and work can also be seen. In some situations, a particle could possibly have both gravitational and elastic potential energy stored in it if the particle is subjected to both corresponding types of forces. In these types of situations, the stored potential energy of the particle is the sum of the gravitational and elastic potential energy, which we can express mathematically as follows: V equals Vg plus Ve. We call this function a potential function of which the magnitude depends on the location of the particle related to a datum that we have chosen. Hopefully, after watching this video, you have learned what is the potential energy of a particle, of which gravitational and elastic potential energy are the most important ones in the field of mechanics. Thanks for watching and have a nice day.